The semiconductor industry is no longer just about consumer electronics. It is the new oil, the foundation of modern military power, and the heart of the global economy. As the world transitions into an era defined by artificial intelligence, nations are realizing that whoever controls the production of these microscopic chips controls the future of the planet. We are currently witnessing a $500 billion global arms race, but the weapons aren't missiles. They are mega-fabs. These are the most complex structures ever built by human hands, requiring environments 10,000 times cleaner than a surgical operating room, and machines that use liquid tin and lasers to print circuits at the atomic level. This is the story of the semiconductor megaplants, the billion-dollar fortresses of silicon that are rewriting the rules of global power. To understand why a single semiconductor factory can cost upwards of $30 billion, you have to look past the steel and glass and into the clean room. A modern mega-fab, like TSMC's Fab 18 in Taiwan or Intel's Ohio Silicon Heartland project, is an engineering marvel designed to eliminate the greatest enemy of the digital age: a single speck of dust. If a particle of dust lands on a silicon wafer during production, it can short-circuit an entire batch of chips. These facilities use massive HVAC systems to circulate air through HEPA filters, ensuring that there are fewer than 10 particles of dust per cubic foot. The structure itself is a masterpiece of vibration control. The waffled concrete floors are several meters thick and anchored to the bedrock to ensure that even the vibration of a passing truck miles away doesn't disrupt the extreme ultraviolet EUV lithography machines. These EUV machines, produced primarily by the Dutch firm ASML, are the most complex pieces of equipment ever made. They cost $200 million each and use high-powered CO2 lasers to blast droplets of molten tin 50,000 times a second, creating a plasma that emits light at a wavelength so small it can print transistors only a few nanometers wide. Building a megafab isn't just construction. It's the creation of a stable, microscopic universe where the laws of physics are pushed to their absolute breaking point. The world has entered a period of silicon nationalism. For decades, chip production shifted to East Asia for cost efficiency, leaving the US and Europe vulnerable to supply chain shocks. The response has been a tidal wave of government spending. In the United States, the CHIPS and Science Act has unlocked over $52 billion in subsidies to bring manufacturing back to American soil, leading to massive projects in Arizona and Ohio. China, meanwhile, is countering with its Big Fund, pouring an estimated $140 billion into domestic players like SMIC to achieve silicon self-reliance. This isn't just about business, it's about national security. Semiconductors are the brains of F-35 fighter jets, hypersonic missiles, and autonomous drones. If a country loses access to advanced chips, its military and economy instantly become obsolete. This has turned the construction of megafabs into a high-stakes game of territorial defense. Taiwan, which produces 90% of the world's most advanced chips, refers to its semiconductor industry as its silicon shield, believing that the world, specifically the United States, cannot afford to let the island fall, because the global economy would collapse without its megafabs. The hidden controversy behind these gleaming megaplants is their staggering environmental footprint. A single megafab can consume up to 10 million gallons of water every day to wash silicon wafers. In regions like Arizona or Taiwan, which face frequent droughts, this creates a direct conflict between the needs of the multi-billion-dollar tech industry and the needs of local agriculture and citizens. During Taiwan's 2021 drought, the government was forced to shut off irrigation to 183,000 acres of farmland to ensure that the chip factories stayed online. Furthermore, the power requirements are astronomical. A modern fab requires roughly 100 megawatts of electricity, enough to power a small city. This energy must be perfectly stable. A power surge lasting even a fraction of a second can ruin millions of dollars worth of wafers. This massive demand for energy and water is leading to a growing backlash in communities where these plants are being built. Critics argue that while the chips are small, the ecological shadow they cast is massive, and that governments are prioritizing industrial output over environmental sustainability. The final, often overlooked challenge in the global chip war is the people. You cannot simply hire standard construction workers to build a megafab. It requires cleanroom certified pipefitters, ultra-high purity welders, and engineers with PhDs in materials science. Currently, the industry is facing a massive talent gap. In the US, projects like the TSMC factory in Arizona have faced significant delays because there simply aren't enough local workers skilled in the ultra-specialized installation of EUV equipment and high-purity chemical lines. This labor shortage has led to intense corporate poaching and rising costs. There is also the grueling work culture associated with these plants. In South Korea and Taiwan, fab life involves high-stress, 12-hour shifts in full-body bunny suits, where the pressure to maintain 100% yield is relentless. As Western nations try to replicate this model, they are finding that the cultural and labor expectations of the semiconductor industry are difficult to export, leading to friction between management and local labor unions. The $500 billion global chip factory war is the ultimate testament to human ambition. We are building the most expensive and complex structures in history to create the smallest products in history. These megafabs are the cathedrals of the 21st century, monuments to our obsession with data, speed, and power. As the lines between technology and sovereignty continue to blur, these silicon fortresses will determine which nations thrive and which fall behind. Whether this leads to a new era of global innovation or a fragmented world of silicon walls, the race to build the perfect chip is a journey from which there is no turning back. We have staked the future of our civilization on the success of these megaplants, proving that in the modern age, the smallest things truly carry the most weight. The war for silicon is reshaping our world. But is the $500 billion price tag worth the environmental and social cost? Would you live near a megafab if it meant your country controlled the future of AI? Let us know your thoughts in the comments below. If you found this deep dive into the world of semiconductors fascinating, make sure to like this video and subscribe to Mega Projects Hub. We're just scratching the surface of the projects that are building our future. Don't miss our next episode on the world's most secure data fortresses.